Hello, PyCon. I'm so pleased to be here. One reason I'm excited to be here is that PyCon Canada is the first conference, like big tech conference, where I ever gave a talk. And like speaking here was one of the things that like gave me the confidence to like continue giving talks. So I was so honored to be invited back. And I've had such a good day so far. Okay, so today we're going to talk about one of my favorite topics, which is being a wizard and like doing magic with computers. A key issue with being a wizard is obviously that computers aren't magic. And so we're instead going to talk about mostly much more pedestrian things, like learning hard things and like how do you build powerful systems. And like I think one thing Camille said in her keynote this morning was she was like the systems we work with are constantly changing, right? So the only way you can like do amazing things is by like continuously learning all the time. And one of the themes throughout this talk is like this idea of a fixed mindset versus a growth mindset. So a fixed mindset is where you're just like, I'm just not good at this, right? I can't do it. And with a growth mindset, you're like, oh, if I spent like 2 months learning this, I'm pretty sure I would know it better, right? So like, what does spending 2 months learning something look like? Here are a bunch of like buzzwords that I learned about this year. It's not really important what any of them are. This is the kind of thing I currently spend my time learning. This is mostly to say I spend a lot of time thinking about how to learn new things. So we're going to talk about like 5 like pretty concrete wizard skills in this talk. We're going to talk about understanding abstractions, asking really good questions, reading your code, debugging, and designing. Okay, so understanding your abstractions. I think that one of the reasons that programming is so exciting and the reasons that we can build amazing things using programming is because you can like build on different layers of abstractions, right? You have like maybe a browser, and then you have HTTP, and then suddenly you're building things where like thousands of people all over the world can talk to each other, and you're like, oh goodness, wow. We have a lot of different kinds of abstractions we work with, right? Like maybe you have TCP, you have HTTP, you have like libraries you work with, like async.io, you have programming languages like CSS, you have data structures like dictionaries, you have fonts and like wireless. How does wireless work? Who knows? And I think one of the key skills, I was talking to someone this morning about like an issue that beginner programmers often have, which is like sometimes you get caught up in like you're trying to understand an interface or an abstraction like HTTP, and you get caught up in like everything that lies underneath that interface, right? You're like, but then what happens on the computer, and how many programs are there, and what's the protocol, and what's a network packet, and like what's IP, and like you kind of can get lost, right? In like all of the details about how everything works. And so I think a key skill that we learn early on is how to like split out like understanding an interface from understanding what's underneath that interface, right? And you're like, okay, I do not fully understand everything about how CSS is rendered, but I do understand like the basic interface of like CSS, and I'm just gonna stick with that for now. I want to give a couple of examples of like how this split works for different things. So for dictionaries, for example, you have a pretty simple interface, right, where you're like you can set and get keys from a dictionary. And a key part of the interface of a dictionary is also that it's fast, right? And then what's underneath that is you have things like dunder get and dunder set. You have hash functions, and you have like whatever like the CPython interface, the CPython implementation of a dictionary actually is. And with something like TCP. I think about networking a lot. So the interface to TCP is kind of amazing. You open a socket, and then you send someone bytes somewhere in the world, and then the receiver receives all of those bytes reliably in order, somehow. And then underneath, there's like a lot of details about how that actually works. This is like a pretty simple interface, like at least the basics of it, and it's kind of amazing that it works, right? And you don't need to understand anything about what's underneath to use it. Okay. So you don't even always need to understand how your interfaces work. For example, with wireless, I saw a talk once about how Wi-Fi works, and there was a lot of cool things about beams, and I did not fully understand. But my main interaction with Wi-Fi is I enter a username and password, and I am on the internet. And that's it, right? So you definitely don't always have to understand your interfaces, and you don't have to understand like how they work underneath. But like, when is it worth like trying to understand something better, right? Because I do spend a long time like worrying about what's underneath the interfaces that I use and trying to learn that better. So when should you do that? I think that there are sort of 3 reasons why you might want to like take an interface and start looking underneath it. One reason is if you're trying to debug a really hard problem. So like, let's say I had like a TCP issue once where like because we'd misconfigured the way we were creating the TCP socket, our network thing was too slow, and like in order to debug that effectively, we needed to understand how TCP worked under the hood, right? And so when you have a really hard problem, you can't just like be smart, right? Like magically, you need to actually understand sometimes the details of how the interfaces that you work with actually work. Another very similar reason is when you're trying to optimize something or push its limits in some way. Then you can't just be like, oh, like dictionaries are fast, right? Maybe you need to know like exactly how fast are dictionaries, and when like maybe using a dictionary isn't appropriate, or maybe I need to use something faster. And the third time is when you're trying to innovate, right? Or if you're trying to build something new. Like let's say I'm building a library like async.io, which is this like eventy library. It's not enough just to understand the interface to async.io to do that. I need to understand like the underlying like technology underneath it, like select or epoll or all of these things that async.io is built on top of, right? And whatever its equivalents are on like BSD or Windows. Okay. So it's really useful to understand your interfaces. I'm not going to talk about this so much because I feel like this is pretty well covered. Like, there's a lot of like documentation about like how to learn an interface, right? Like maybe you read the docs or you build something fun with it and you see how it works. The only thing I want to say about understanding interfaces is that when I'm trying to learn a new interface, I often like to like pick interfaces that will like help me like do work across multiple platforms. So like HTTP I think is a really important interface where you learn how GET requests work and how POST requests work, and you learn like what an HTTP header is. And if you're a web developer, that's a really key interface to master, right? Because then you can continue to use that no matter what programming language you're working in. But what I'm going to talk about instead is like, how do you like understand what's underneath your interfaces, right? Like supposing that you've decided to do that and you're like, okay, I want to get super good at this. I want to like innovate, or I want to like push the limits somehow, or if I have like this problem I need to debug and suddenly I need to know how TCP works. And like a lot of the work I do here, like for myself, is I'll like invest in something in advance. So sometimes I'll be like, this seems like it could be cool to know more about, and I'll invest in like maybe learning how TCP works at some point, just because I think it'll be cool. And then like 2 years down the line, I'm like, oh, I'm glad I did that because now I have this like super weird bug and I'm equipped to handle it. So these are not these are mostly like kind of fun experimental things. So one thing you can do is you can do something like push that interface's boundaries, and you're like, what if I do something weird with this? Like, what happens? A really simple example of this is like, let's say you're interested in the interface of threads in Python, right? And you can be like, okay, let's say I create 100 Python threads that are all doing a lot of calculations, right? How many CPUs does that use? And the answer is 1. Which is like sort of surprising, right? Because I have several CPUs, which is because of the global interpreter lock, right? And I mean, you could argue that the global interpreter lock is like part of the threads interface in Python, but it's like not totally obvious to start with that it is, right? So now we've understood a little bit about like what lives underneath that interface, and we have like a more nuanced understanding of it, which is important. One thing that I think is extremely fun to do, and I think I've talked about this a lot on my blog, is like the pattern of like build one yourself, right? Like make your own HTTP server if you want to know how an HTTP server works. Make your own database, make your own gzip. What could be better? I think about like the implementations like this that I do as being like experiments, right? Like I'm not trying to build the next best like amazing TCP stack, so I have some rules for like programming experiments like this. The first rule is that it doesn't need to be good. And the second rule is that it doesn't have to work, but the point is to learn, right? So if you're building, let's say, a database from scratch, like this isn't necessarily going to be a database that anyone uses, but I think implementing even a very simple database can teach you really important things about how databases in the world actually work, right? And then you can kind of like hide it under your bed or in your GitHub and like never use it in production and go back to using normal databases. But I find this to be really powerful. Another thing I like to do sometimes is like read things that are like too hard or that are challenging for me. An example of this is there's this website called jepsen.io, which does analyses of like what happens if you break Elasticsearch, and it uses a lot of words like linearizable, which I did not understand what they meant when I started to read these analyses, but reading them helped me learn a lot, right? And I looked up these words, and now I know a little bit more about database reliability and what the word linearizable means. And another, this is more of a thing that you can do like day to day in your job to make sure that you understand the interfaces you're working with. So a lot of the time, sometimes I'll be using an interface and something will happen which I don't understand, right? Like I had a computer once that was swapping and I didn't know why. I was like, it shouldn't be doing that according to my like mental model of how like swap works. And so sometimes you have to like be like, I don't understand this, I'm gonna let it go for now because maybe you have a deadline or like work to do or something. But I think often it's actually important to stop and be like, no, I need to understand this and I'm going to spend the time to figure it out. And I think this is actually very important for me at work. Like for example, recently on my team, we rolled out a change that broke something and then we rolled it back, right? And everything was fine. But then the next day, what I realized is that nobody had actually, like, we hadn't really fully understood what caused that to break, right? And, like, no one had figured it out yet. And so I was like, wait, before we, like try to roll out this change again with our, like, attempted fix, we need to make sure that we take the time to understand, like, exactly what happened, right? And what the underlying cause was. And I think if you, like, kind of, like, make this like continual investment in making sure that like you understand the interfaces that you're working with, and when something weird happens, you're like, no, that's not what I thought was going to happen. That it didn't happen for a magical reason. I'm going to find out why. It can really take you a long way to becoming a better programmer. Okay. Next wizard skill we're going to talk about is asking great questions. One concern I hear from people sometimes about asking questions is they're like, oh no, if I ask questions to my team at work, they'll find out I don't know things, which is true, they will find out you don't know things. But I ask an extremely large number of questions at work. I don't think it's really decreased over time. I just ask different questions now. And one thing my managers have always told me is that they feel like they can trust me to like not get stuck and just like flounder like a fish, because they're like, well, I always know if you get stuck, you're going to ask someone, you're going to figure it out, and you're going to move on, right? And I think that makes me like a much better developer, and I think of it as being a big part of my job to like ask questions when I get stuck, and I really appreciate it when my coworkers do that as well. So I don't just think of it as something that's okay, I actually think of it as something that I should be doing, right? So, what's a good question? I think there's a lot on the internet written about this. I have a pretty simple definition for myself, which is that it should be easy to answer for the person you're asking the question, and it should get you the information you need. Right? That's it. First cool question asking trick that I love is to say what you know about the problem. You can be like, hey, so I know, like, these are the facts that I know about this database situation. I'm trying to figure out what's next. Or maybe you follow up with a question based on that. And this is great because it helps me organize my thoughts. It often like reveals misunderstandings that I might have, and someone can say, oh, that's totally right, except for like in this one thing that you said isn't totally correct. And it helps me avoid answers that are like too basic or too advanced, right? Which is like get me the information that I need. Because it's frustrating when you ask a question and someone gives you an answer, which is like really like you asked a question and you wanted an answer up here and you got something like down here. And you're like, no, that's not. I know what Linux is. Like, right? And so stating what I know can really help with that. Another thing I like to do is like avoid always asking the most experienced person, because it can be easy to be like, oh, that person knows everything. I will ask them all my questions. And I like to sometimes like find like the person with like the least experience who I think will know the answer to my question. And having been on the other end of that, I remember I joined the team I'm on a little, like maybe a year and a half ago, and I was learning how like all of our DNS stuff worked. And I was so excited the first time like someone came into my channel, into our channel to ask a question, and my coworker was like, Julia, can you answer that? And I was like, I can answer that. I know the answer to that, and I was really happy to like be asked it, right, instead of them going to someone else who knew more. And it helped me like establish my own knowledge. So it's like asking someone questions can like be a way of like helping them in a funny way, right? Yeah, that's what I just said. Cool. Great. You can do research. I think we talk about this a lot when asking questions, so I'm not going to go into it. And okay, so but let's think about like what it takes to ask a question about a really big system, right? Like let's say you're trying to understand like Django or like Linux or like some like huge code base, or like distributed systems, right? It's like, how do distributed systems work? It's like, well, which one, what part, what do you mean? And so I have like a variety of ways I like to ask really specific questions when I'm trying to explore an area. And sometimes even if like it's not, even if like that specific question isn't exactly what I want to know the answer to, often I'll just like be like, okay, what about this? And I'll like poke around and like sort of like put more paint on the canvas in like different places, and until I'm like, oh, okay, I see, I have like a better picture now by like poking in like random places. So one really great form of a like specific question is a yes or no question, right? Like let's say I'm trying to understand a database. I might be like, does that database do hash joins, right? I know hash joins are a thing. I might not know anything about this database. This is a yes or no question. Maybe this person will know the answer to it, and it'll give me like a little tiny bit more insight into like how this database's internals work. Another similar thing I like to do is like guess the answer to my question in advance. So I'll be like, hey, I have this question, and I have an idea about what the answer could be. And I could be like, okay, so is the reason we don't use threads in our Python program because of the global interpreter lock, right? And the person could just be like, yeah. Or they could be like, that's one reason, but there are also other reasons too. And this is also cool, I think, because like it shows the person the kind of answer you're looking for, right? Because if you're like, is the answer to this question X, then they won't like give you a totally different type. It's like try to like type your question, right? Like the right type of, yeah, anyway. Another cool question is like, how did you just do that? Because sometimes like, this is especially helpful if like you have a coworker who has a lot of knowledge in their head and you want to somehow extract that knowledge out of their head, but they don't even like always know that they have it. And so it's hard for you to be like, tell me how you do that. And they're like, I don't know how I do that, I just do it. And so if someone like does something and they're like, oh, I fixed the thing. And then you're like, okay, can you show me how you fixed the thing you just did, please show it to me. Because then they can realize, they're like, oh, that's a thing you don't know. And you can be like, yeah, that's a thing I don't know. Me, I want to know. And as I become a more senior like programmer, one thing I like to do is like continue to make sure that I ask questions in public. I actually always did this, but I think it's important to continue doing it and to be like, I don't understand like how this works, right? Can you explain to me this detail about this system? And I think having more senior people do this helps create the space for everyone to ask questions, which is, I think, is very important. All right. So asking questions is not always sufficient to get you the answers you need. I think increasingly, as I learn more and more things, I run into situations where I'll have a question, and I'll look at the people around me, and I'm like, oh, no one knows the answer to this, like on my team maybe, right? Or I'll Google it, and I'll be like, nobody in the GitHub issues has the answer. Oh no. And so this is where reading the code can come in very handy, because the code frequently contains many answers, which sometimes none of the people around you have. And it doesn't matter if like maybe the code's undocumented, but you can just go look at it and sometimes you can find the answer. I think that they're like the way you read a small code base and a large code base is really different. So with small code bases, I feel like it's really fun. You can be like, oh, I'm just gonna start at like the main entry point for this code and then just like try to read everything. I really like to do that because it makes me feel like I have like some like mastery over the code. And it's sometimes like surprisingly easy. Like I read like there's this HTTP library inside Ruby, and I was like, oh, this isn't that big, I'll just try to read it. And I found some like interesting and surprising things that I didn't realize were there. And I like understood its design a bit better, and it was really cool. But that was only really feasible because it was relatively small, right? An example of this recently is I use this thing called Kubernetes, and it has a cron job implementation in it where it runs like periodic jobs. And the way this code works is actually really simple. It's basically a huge while loop, and it'll be like while true, wait for 10 seconds, and then just like sync everything and try to run any cron job that needs to be running, and maybe do some cleanup. And because this implementation was only like maybe a couple thousand lines, I could just read through it and see how it worked. But with a big code base, you can't really do that, right? You can't just be like, I'm just gonna go read Django, right? Like, it's not really a thing. But this is still something that you often have to do, right? Like in my first job, I was working with a software called Drupal, which is this like PHP content management system, and I was writing like extensions for it. And I was asking my manager at the time, like, how do I, like, I had like a really specific question about like how something worked, and I was like, how does it work? And he was like, I don't know. And I was like, it's not documented. And he was like, yeah. Like, this is like your moment of truth when you realize you just need to go read the Drupal source code to figure out how this thing works, right? And I was like, oh, that's allowed? Like, that's cool. But so like, how do you do that, right? And I feel like kind of similarly to like understanding a large system is like the way for me to like read a huge code base is to like ask like extremely specific questions about it, like like as specific as possible. I think the simplest question you can ask of a big code base is like if you get an error message where someone printed like a perhaps unhelpful error message like, oh, the thing is broken, which none of us have ever done. You can grep for that error message, right? And then go read the code around it and try to see like what actually happened. Another related thing you can do, except in the less error case, is like you can search for strings from the UI, right? Like if you want to know how a component works, you can be like, okay, here's what I'm seeing in like the user interface, and then go backwards from there, and maybe you find that in a template file, and then you find where that template file is referenced, and then you move back, and then maybe eventually you find the code that you're looking for. I used Neopets a lot when I was in grade 7. That's all. Another thing that I think is kind of fun to do is like look for some like really specific code that I expect to be there. So like someone wrote a blog post recently about async.io, and I had some questions about it, which were not answered in the blog post. And then I was like, well, like, what if I was trying to learn about async.io, right, which is this like async library for Python? And I was like, well, it has an event loop, right? We heard about event loops in the last talk in this room. And I was like, well, if there's an event loop, there must be a loop, right? It's right in the word. Where's the loop? So it's here. I went looking around for loops. And I found it in lib/async.io/baseevents.py, which is 1,400 lines. And on line 419, there's a while loop, which says while true, run the thing, and then if you're supposed to stop, then break. And I felt like so like happy about my increased mastery over async.io. I was like, I get you. Like, you can't trick me. The event loop isn't that complicated, just a loop. It's right there. What's the problem? And I really felt like I could answer any question about this library now that I had the event loop in my hands. Another, I think, fun way to read code, especially like maybe your coworkers' code, like if you've joined a new company, or if you have a new code base which has all kinds of like exciting, confusing things in it, is to like, like one thing that sometimes people do when they have a new code base is they're like, I'll refactor it and I'll make it better, right? Which is a little dangerous, because basically you run the risk of like you then understand it better, but then no one else understands it, and now there are more bugs. Probably because refactor like equals bugs, I think, is how it works. So a fun trick I learned from Lindsay Cooper is you like refactor the code and then just put it back the way you found it, and then nobody knows you refactored it. But you still have like learned some of the useful lessons that you could have gotten from the refactoring, right? And you are saved a lot of the trouble of making your refactor actually work. And you can just make it a learning experience without all of the bugs. Another fun thing to do is to put in print statements, right? One evening, I was like, I'm gonna understand SQLite a little bit better. And so SQLite is this like really simple SQL engine. You can just like install it on your computer. And so I was like, well, how does a select statement work? What happens when you do a select? So I like looked around and I tried to find somewhere I could put a print statement in that I thought would be executed during a select. And I found somewhere and I put some print statements in, and then I recompiled the code and I ran it, and then I ran select statements on my laptop, and then my code ran. And I was like, I know how SQLite works a tiny bit more. Like, I know that this one function executed 4 times, and like maybe a little bit about what some of the parameters were that I printed out. And and then I ran like different queries, and I was like, oh, if I do a big table, it gets printed out so many more times. That makes sense. I am a genius. But no, I mean, not really, right? It wasn't that hard. One final thing about reading code is that I think it's useful to remember that like comments and documentations aren't always 100% accurate, which is fine, right? Like it's like the human condition is like having inaccurate documentation. This is a really small example, and this is something which is like mostly, so I was using this Kubernetes thing, and it said like every Kubernetes cluster has a cluster root certificate authority. And I read the sentence and I was like, oh, it has to have just one? That's not what I want. I'm mad. I want to have two because of reasons. It's not important why. And then I thought about this for a long time, and I was like, oh no, this isn't true. What I want to be true is true. And then I was really happy. So I think it's just important, like when you read things, just like this sentence was like mostly true. It was like useful, but like even if like documentation can be useful without being like totally correct, right? And so I think it's useful to remember that comments and documentation are not like gospel, and to be a little skeptical. All right. We're going to talk about my next favorite thing, which is debugging. You may notice I have a lot of favorite things. I'm sorry. So this, I think, segment is alternately called Love Your Bugs, which is the title of an excellent keynote at PyCon Brazil by Alison Kaptur, which is about like why bugs are something that you should love and cherish. I made these ones really cute to make you try to love them. I will try to do that also through like facts and not just pictures of like caterpillars. All right. So one reason that debugging is useful is that it helps you learn like where your mental models are wrong. So for example, a mental model I used to have was that when you open a file, you can open files, right? And I was like, oh, I think I can open as many files as I want on my computer, right? I can just keep opening files forever, which is not true. There's a limit to the number of files you can have open, and if you do too many, you will get an error, which is something like too many open files, right? So this is sort of like a new bug, right? And the first time you see this bug, it's like a new species, and you'd be like, oh, there's a limit. Cool, good to know. Now I know for next time, right? And then you've like improved your mental model about how like files work, right? And like the file interface and like what's underneath it. Because before you were just like, oh, files, you can just open them, cool. And then you're like, oh, there are weird special cases. Debugging, for a similar reason, I think debugging also makes you better at writing reliable code. I have this like model in my head, and I think all of us do, which is like you have like this sea of different kinds of like possible errors and bugs that you can run into, which all happen with like varying frequency, right? Like for example, in Python, it's really easy to make a typo and have a bug because of a typo, and like that could happen like if you don't pay attention or if you don't like write a good test suite, then this can happen constantly, right? And there are things which are a little less frequent, but it can still happen, like having a corrupt hard drive. And there are things which like almost never happen, like bugs in your compiler, right? But are still possible, because like nothing like never happens, right? And I think it's really useful to kind of have like a mental menagerie of bugs like this, because it lets you, like, it informs how you do your error handling, right? Because you can't like you always have to like prioritize when you're writing your code, so you can't just like treat all possible kinds of bugs equally and be like, okay, it could just as likely be a typo or a compiler bug. It's probably a typo, and it means that you can build like systematic mitigations for these classes of bugs, right? So you can be like, oh, I know typos are really common because of humans, and so I'm gonna write a better test suite just to make sure that we don't, or maybe I'll use a linter, right? And we'll do linting on all our code, and then we'll be less likely to have typos, which is great. Or maybe you know that corrupt hard drives are a possibility, so you build in replication. And like depending on like how important your data is, or like how many hard drives you have, maybe you spend like more or less effort on this kind of issue, right? So like how do you get better at debugging? I want to talk about a couple things that help me. One really simple thing, possibly so simple as to not be helpful, but it's just like remember that it's happening for a logical reason. It's sometimes very tempting to be like, oh, that could never happen, and you're like, well, actually it did. So why did it happen, right? And maybe investigate. I think another useful thing is to kind of like I think maybe confidence is not the best word here, but like to be tenacious. There was this really great talk earlier today about like a bug that took them 6 weeks to debug, right? And I thought a really cool thing about that talk is they demonstrated how, like, even when dealing with a very challenging bug, they managed to make progress over time, right? And they were like, okay, we did this, and then we were really confused for a while, and then we thought of another step, and then we took that step, and then we were really confused, and then we came up with another step, and they just like continually like inched closer and closer to a solution to the problem, which is something which I look for also like when I interview people, right? I'm like, oh, if you're debugging, are you kind of like moving closer, even if there's sometimes like missteps, right? Which we all make, but like, do you have like a plan about how you're gonna collect more information? A couple of years ago, I was trying to fix a Hadoop job that was really slow, and I worked for a long time on fixing it, and I think I felt good while I was doing it because I was like making continual progress, and I wasn't just sitting there like in like a pile on the floor being like, why? Like I managed to find ways to make progress, but it was a little nerve-wracking while doing it too, right? Because it took me 3 weeks, and I was worried that like if like I spent 2 weeks on it and made no progress, then like my manager would be mad because I'd be like, sorry, I didn't manage to actually do anything. But I did fix it, right? And I think as long as you are making progress, you can fix things. One interesting thing I learned throughout the course of solving this bug is that like processing 1,000 records a second isn't a lot. I had a lot of discussions with people about this because I was like, is 1,000 records a second a lot? Like, isn't a millisecond a long time? I don't know. It kind of seems like a long time. It's Java. Is it a long time in Java? Is it a long time in Python? Like, how long is a millisecond, right? And I think it like made me want to train my intuitions a lot better to be like, no, a millisecond is too long. I'm mad about that, right? And I think it's useful to have these kind of intuitions where you're like 3 milliseconds. Like in the talk right before this, he was saying like we have 1,000 employees at Pinterest. Like going through that list and seeing whether someone belongs to that list should not take 3 milliseconds. That's stupid, right? Like that's too long. Which is not to say that the person who wrote the code is stupid, but just like that is like longer than that piece of code needs to take, and there's probably an opportunity there to improve it, right? To be clear. So it's like, where are the opportunities? I want to play a quick game. Do you want to play a game with me? Yay! At least one person wants to play the game. So we're playing the game. This game is how many things can your computer do in a second in Python? This is a game I wrote with Kamal a couple of years ago. Okay, which one are we going to do? We're going to do dictionaries. Okay, so the goal here, you probably can't read this, but it's okay. I'll play for you, and I'll read it to you. How many entries can you add to a dictionary in 1 second? 10 million? Okay, great guess. Let's guess that. You're right. It's 11 million. That's so many. Who said Python is slow? Let's say we want to write some data to memory. So what this does is it like creates a really big string and like puts it in memory. So like how many megabytes or gigabytes or kilobytes can you like put in memory on my laptop? It looks like this in a second. 10 gigabytes? Okay, let's guess 10 billion. I think I only have 1 billion. It was 2 billion. I could do 2 gigabytes in a second. You can run out of RAM so fast. It's amazing. We can do one more, which is like so. There's an HTTP request parser that's part of Python. It's written in Python, and like how many HTTP requests do you think we can parse in 1 second with this like pure Python HTTP request parser? 1 million? Okay, I heard a lot of different numbers. 100,000 was the loudest one. It's 25,000, which is a lot less than like. Anyway, so we have all these different numbers. And one thing that I think is interesting is like we got all these like really different estimates from the crowd, right? And it's a lot of the time it's really not obvious. But I think it's possible to develop like slightly better intuitions about these things, and it can be good for working on performance. Okay. Another useful thing is to know your debugging toolkit. For example, like let's say you're trying to fix a profiling problem and you want to actually have a profiler. When I used to not have a very good debugging toolkit, then I got kind of obsessed with it. I wrote a zine about debugging tools for Linux, which we're not going to go into. but like having the like concrete tools you need to answer the questions that you're asking, which I'm sure are extremely good, like how much time is being spent in what functions. And if you actually have those tools, then you can do a much better job of debugging, right? And of course, like I learned to like it a little bit more. I used to be like, oh no, there's a snail. I've never seen a snail before. What do I do with a snail? I just want my code to work. And now I'm like, oh, a snail. So interesting. Like, I can add it to my collection of things I know about that can happen on a computer. Like, I feel like so someone told me that they had a database, like a MySQL database, and if you selected a row, like a specific row, a particular row from that database, all of the other rows were okay. But if you selected this one row, the database would crash. And I was like, a computer? That can happen? Cool. Interesting. And I mean, it was more cool because it wasn't happening to me. Which is, I think, another important lesson here, which is like share your bugs with other people so they can experience like the joy and wonder while you're stuck solving them, and at least like you all get something out of it, right? I feel like bugs are like an important social activity for that reason, which is why we had like a whole talk about a bug that someone solved. It's kind of wonderful. Okay, our last big section is about designing software. So we've been kind of in the guts, and we've been debugging things and coding and using abstractions, and now we're like, okay. One, I think, really unfortunate situation to be in is if you're coding something and then you step back and you're like, why am I doing this? What's the point of this? I once spent like 9 months working at a job where nobody ever used any of the code that I wrote, which was frustrating, and then I quit, which I'm happy about, and now my life is better. But like, this is not a situation you want to be in, right? Like, you want people to use the code that you write, and to use the work that you do for it to be important. So planning is useful. It's useful because it helps you keep track of like, why are we doing this? And you can like make sure you're on the same page with other people. You can be like, I think we should be doing this, and this is the plan. They're like, yeah, sounds great. And I think, and the last reason I think planning is useful is it helps you like make sure you don't miss like obvious future problems, right? Like that you could have like easily foreseen. Planning and design are also really hard because you can't really like predict the future. I normally hate to use metaphors, but we're gonna try a metaphor anyway. Like if you're designing a house, you want to know like maybe how many people are going to live in the house, or like maybe you're designing a house for your family to live in, right? You're like, okay, how many people want to live there? Are there earthquakes? Slash like, are we going to be attacked by hackers? Like, are we going to rent out the basement? Like, you have all these different factors that you want to like use, right? And you can't really predict a lot of them. Like for example, with houses, you might be like, oh, we have an extra human to put in our house. And I mean, so often these surprises are like good, right? Like you can be like, oh, we have extra customers, right? Or we're getting like more web traffic because we're like too successful. But then like you have to do extra work, or maybe you need to redesign your systems. And I think this is like fundamentally a hard problem, and I kind of shied away from it for a long time because I was like, I don't know, there's the future. Who knows what's in the future? Why do you want me to design this? I don't know what's in the. Who do you think I am? But no, we have to design anyway, right? Like writing designs is useful, and so like we need to do it anyway, even in the face of a lot of like uncertainty, which I find very hard. But so like here are a couple of like really small strategies that have helped me a little bit. So one thing that helped me was to like start out by designing really small projects. So for example, like earlier this year, I needed to do a little project that it was a pretty important project. Like I was only going to spend like a week on it, but we really wanted to make sure to get it right because it was like important for the company. So I spent just like 30 minutes being like, because I agreed to do it, and then I spent 30 minutes being like, this is my plan. And I wrote it up, and then I sent it to a manager on another team, and I was like, hey, can you just look at this and make sure that this is a good plan? And he was like, thank you for writing the plan, because I wanted to make sure we got this right. And then he was like, oh, I have like a couple of small edits, right? And then I incorporated his changes, and then I went ahead and I did the project, and it all totally worked, right? And it made me feel really good about writing designs, because it had like such an immediate payoff, right? There's obviously some danger here. Like I've definitely worked on like trying to design projects, especially I think when I was like earlier, like smaller, where I would sometimes be like, this is the plan, and then people would be like, I have 3,000 different kinds of conflicting advice for you, and I was like, oh no, I'm sorry. But I don't know, I've gotten better at this over time somehow. I don't have any advice about that, actually. But another thing that helps me is to write the announcement email first before. So when I finish projects, I'll often write an email being like, "Hey, this is what we did. This is why it was important." And we have like a pretty clear format for how we announce projects. So we're like, "Here's like what the problem was and like why it was important to do this project. Here's what we did." And here's how we know it's working. Ideally accompanied by like graphs, where you're like, before there are errors and now there are no errors, right? Like, but not always accompanied by graphs. And writing this email in advance, I find helpful because then I'm forced to articulate like, why is this important? What are we going to do, right? And how will we know it's working? And I find this like narrative form where you just like write an email explaining sometimes easier than like a more formal document where you're like goals, risks, like. Yeah, so I really like this format, and it helps. Like personally, it helps me think. I think because I think about projects often in a very like narrative way, and it feels less stressful. Another thing I read about once, I've never done this, but it just seems like a cool idea. So take it with a grain of salt. Is like to write like a post-mortem for a project and be like, this project failed. Why did it fail? And then like write down all the reasons why it could have failed, and then maybe like try to prevent them. Though it's like important also to not get like too wrapped up in like imagining reasons you could fail and just like hiding under the couch. Like it's just good to like consider some things, be like, okay, here are some like actions I'm gonna take and then move on, right? Because you can't predict everything. You just need to like come up with a plan. This is another really cool strategy is to make a proof of concept and code something to start. This is a story from my partner, Kamal. So he was interviewing for a job a year ago, and in the job interview, they were like, "Hey, we're like thinking of building this Android integration, but like we're like not sure of like the technical details of how to do it." And he was like, "Interesting. I have ideas about that." So he went home and thought about it, and then he whipped up a prototype of how to make it work, and like just like put it on his blog, and it was like no big deal. And then they like discovered it, and they were like, "You built a proof of concept of how we could solve this very important problem for us?" And then they were like extremely excited about hiring him, right? And now he's working on that project. And I think like there's something that's just like so powerful about prototypes and proof of concepts that can like help you, because like you can sometimes spend too much time like writing or designing things and be like, what are all the things? And then if you have like a thing that works and that you can see working, you're like, oh yeah, that works. That sounds good. Let's do that, right? Like prototypes are amazing, and I think they're very powerful. And they can like take you, like you can like build a prototype and then like go in that direction for like a year, right? Which I think is really cool. Something else that's very important for me to remember about design is I kind of get stressed sometimes when I'm designing projects, especially when I'm in like a confusing space, because I'm like, oh, I can't build, like I know that there's a good design out there and I can't see what it is, and I'm like, this thing that I've designed is terrible and I don't want to show it to my coworkers, but you kind of have to, right? Like I'll often like write down like, I'll be like, here's my idea, and then I'll be like, here it is, and it's kind of like a person with like their head on their foot, and they're like, okay, like maybe make it like symmetrical, right? And then you have like two heads, one on each foot, and then you're like, oh, maybe the head should go on top, and then you're like, oh, maybe just one head. And like it seems like very obvious and funny at the beginning, right? But like a lot of the time when you're like in the woods of trying to design something, you don't know, right? And sometimes you don't like, the issues you're going to run into aren't obvious to you. And I think it's important to it's important for me to realize that like I am gonna build things that are kind of like this, like with the person with the, because it's pretty good, right? It's symmetrical, and like the person can still see, like like a good balance. There are a lot of like pros to this design, and then to like redesign blamelessly later, right? And instead of just being like, oh, like what idiot built that, just be like, okay, like we built that design and we tried our best, and then we learned some things from it, and then we'll make some changes, right? And like sometimes like this like weird thing that you build like lasts, and maybe it works well, right? Like for a couple of years, and then there are issues, and then you fix the issues, and then you keep going, and then that's it. And I found it kind of like freeing when I realized that. So that's all the wizard skills that I have for you right now, and we're also kind of out of time, which is good. It's good that those two things happened at the same time. The very last sentence I wanted to say is I think it's been important for me to like take on hard projects, A lot of the times when I have like this like bag of skills, right, where I'm like, okay, I know like a couple things, and I often imagine like when confronted with like a hard project that there's like someone else who should be doing it. I'm like, maybe someone who knows about this should be doing this project and not me. But the issue is that this person doesn't exist, right? Who knows how to do everything, and often the person who is actually exists and like works for the company and can be assigned tasks or whatever and can run projects is me. And being real is like a key advantage in doing programming work. And so I would think it's useful to remember that you are a real person, and in contrast to that other person who may exist somewhere in the world but likely not, they're not likely not available. So maybe ask questions, maybe read something hard for you, maybe find an abstraction that you always want to know how it works and find out how it works under the hood, maybe read some code, maybe do a hard project, and be a wizard. Thank you.